Hi guys, in the previous video we have learned about Laplace of derivatives, therefore here we will learn about Laplace of integrals. Now again, if we have a Laplace transform of ft which is equivalent to fs in the spatial domain, therefore the inverse of this Laplace transform is basically the original signal in the time domain. Now, if ft is integrated from 0 to tau, its Laplace transform is basically 1 over s fs. So this implies that the inverse Laplace transform of 1 over s fs is equivalent to integration of ft in the time domain from 0 to tau. So what we have demonstrated just now is the theorem of Laplace transform of the integrals. Now let's demonstrate with an example hs equivalent to 1 over s multiplied with s squared plus omega squared, and you're being asked what is the function in the time domain. So here you know you need to find the inverse Laplace transform. Okay? So first thing first, we divide hs into two separate components, which is 1 over s multiplied with 1 over s squared plus omega squared. And we realize that 1 over s here corresponds to the theorem of Laplace transform of integrals. Okay? Now, next, let's assume 1 over s squared plus omega squared is equivalent to fs, whereby this fs can be multiplied with omega over omega. As such, we can take 1 over omega out, okay, and we can derive the ft from the basic Laplace transform table as 1 over omega sine omega t. Therefore, here we can summarize ht as the integral function of ft from 0 to tau. As such, it is equivalent to 1 over omega integral of sine omega t dt from 0 to tau. So this is equivalent to 1 over omega cos omega t. Don't forget your negative here, over omega, and it should vary from 0 to tau. And our final answer is negative 1 over omega square when we substitute the t equivalent to tau and 0 here. And when it is equivalent to cos 0, it is equivalent to 1. So our last answer is 1 over omega square 1 minus cos omega tau. Okay, now we know that when ht is equivalent to 1 over omega square multiplied with 1 minus cos omega t, the Laplace transform hs is actually 1 over s multiplied with s squared plus omega square. Therefore, let's go to another example where we need to find the value of kt when given a function in Laplace ks equivalent to 1 over s squared multiplied with s squared plus omega squared. Now, since ks is actually 1 over s of hs, therefore kt is basically the integral of ht from 0 to tau. Okay, we know this from the theorem of Laplace transform of integrals. So from here, the answer to this is we substitute the value of ht inside this integral. Okay, let's not forget your dt here. And the results of this integral is 1 over omega square t minus with sine omega t. Don't forget over omega, and it should vary from 0 to tau. Now, this is equivalent to 1 over omega square tau minus sine omega tau over omega minus 0 plus with sine 0 over omega. Alright? Now, let's just try to solve these two components here. They are both equivalent to 0, so let's just get rid of it. So, your answer here is tau over omega square minus with sine omega tau over omega cube. So that's it for this video, guys. Thank you and all the best.